Welcome back to Get Your Nerve On. I'm your host, Sarah Zimmerman. Your contestants for this week are Andrew Parker, Catherine Wang, and Derek Chen. All contestants will start with their resting potential score of -70 millivolts. Contestants will earn 3 points with each correct answer, all of them trying to reach their -55 millivolt points first to reach their action potential threshold. This is a lightning round, so let's get started. The first category is general neuron information and structures. Question 1. What are the 3 main classes of neurons and which ones are found most often in the sensory system?
So it's monopolar, bipolar, and multipolar, and the first 2 are found more often in the sensory system.
That's right. Because there's not as much need for integration there, you can simply do the processing of sensory information. And next question, which structure is the deciding factor in whether or not the signal will travel down the neuron?
It's the axon terminal.
That is incorrect. The answer you're looking for is axon hillock. Next question, which structure can lead to high neuron damage if degraded and even cause neurodegenerative diseases?
The myelin sheath.
Correct. And now for our last structure question, who can name all of the structures on this diagram in order from A to Z?
Ooh, I got this one. It's dendrites, cell body, voltage-gated ion channels, nodes of RON VA, and the axon terminal.
All correct. And it's also your lucky day, Andrew, because you have hit a bonus question. Now, can you tell me the difference between the dendrites and the axon terminal?
The axon terminal takes in information from other neurons, and the dendrites pass the signal along to the next neuron.
Almost. It's actually the other way around, though. And that's it for our structure round, and the contestants are neck and neck. But now on to function. The first question, what 4 charged species contribute to the resting potential?
Sodium, chlorine, potassium, and organic anions.
That's right, 3 points for you. And next question, what are the 4 factors contributing to the resting potential?
So it's diffusion or osmosis, electrostatic pressure, passive resistance, and active transport.
Also correct. And for a bonus point, can anyone tell me which of those serve to...
I know this one. Okay, so in diffusion and osmosis, the solutes diffuse to bounce out the concentration, and with electrostatic pressure, there's a drive toward neutrality with positive and negative particles.
Amazing, that is correct. It's almost like you knew what I was about to say. And not only that, but with passive resistance, some solutes move across a semipermeable membrane, and in active transport, the sodium-potassium pump pumps 3 sodiums out for every 2 potassiums in. And now we can move on to the graded potential section. First question, when chloride channels open, what happens inside the neuron?
So it's hyperpolarization, so an inhibitory postsynaptic potential.
That's correct. Our contestants are on a roll. And there's also a small local hyperpolarization where the inside is made more negatively charged due to chloride ions, and this makes the action potential harder to stimulate. Next question, how is the graded potential reduced?
Trick question, they aren't.
Not a trick. The ion channel openings usually only occur in a small area of the cell, so it will not change the potential across the entire membrane. Thus, with time, the ions diffuse out of that small area, and then they're pumped back in through the sodium-potassium channels, and then the potential is returned back to its original state. And now on to our last graded potential question. What is it called when the graded potentials are added together that they may lead to an action potential? And hence,
Summation,
there are 2
right?
types
And
of
then
this.
the 2 types are spatial and temporal summation.
Very fast and very correct. Spatial is when different neurons fire simultaneously, and even though individually, their graded potentials are weak. Together, they build up the charge enough to hit the threshold. Whereas temporal is rapid sequential channel openings that build up the potential enough to hit the threshold. And on to our final category section, the action potential. First question, describe how an action potential travels in a neuron.
Once the action potential threshold is passed in the axon hillock, voltage-gated sodium channels along the axon open and sodium rushes into the cell. As positive charges diffuses along the axon, more voltage-gated sodium channels open and more sodium enters the cell to keep the signal strong. The signal moves forward through the axon all the way down to the axon terminal.
Bingo, that's correct. In our next question, why does the signal not move backwards?
Okay, it's because sodium channels deactivate after a certain level of depolarization and don't reopen until the neuron is repolarized, effectively pushing the signal only in one direction.
Correct. Moving on to our next question. How does the cell become repolarized after the action potential?
Oh, I got this one. So after the sodium channels open, voltage-gated potassium channels also open, hyperpolarizing the neuron. Sodium and potassium pumps then work together to restore resting potential.
That's correct, and if my calculations are correct, I believe we have a winner. Reaching their action potential first is Catherine Wang. Congratulations, Catherine. What message would you like to fire at our audience?
So remember, kids, even if you don't think you have potential, at least you'll have action potential.
And there you have it, folks. Thanks for tuning in, and see you next time on Get Your Nerve On.